Hello everyone, welcome to the solution of LeetCode problem 1298 named maximum candies you can get from boxes. In this problem, you have n boxes labeled from 0 to n-1 and you are given 4 arrays which is status, candies, keys and contain boxes. Where status of I is 1 if the ith box is open and status of I is 0 if the ith box is closed. Candies of I is the number of candies in the ith boxes. Keys of I is the list of labels of the boxes you can open after opening the ith boxes. And content box of I is a list of the boxes you found inside the ith boxes. Now, you are given an initial integer array, initial boxes, that contains the labels of the boxes you initially have. And you can take all of the candies in any open box and you can use the keys in it to open the new boxes. And you also can use the boxes you find in it. Now, we have to return the maximum number of candies we can get by using the following rules. Now, let's consider this example. Here we are given 4 boxes. 2 of them are open and 2 of them are closed. The number of candies presented in these 4 boxes is 7, 5, 4 and 100. And first, second and fourth box does not contain any of the keys, but the third box contains key of the box 1. The first box has box 1 and 2 inside it. The second box has box level 3 inside it and so on. Now, our initial boxes is 0, which is the first box we can start. Now, you will be initially given the box 0 and you will find 7 candies into the box 0. And inside it, we have found box 1 and 2. Now, inside box 1, it is closed. So, till now, we don't have any key to open it. So, you can open the box 2. And if you open the box 2, you will find 4 candies. And in the box 2, there is a key of box 1. So now we will again get back to the box 1 and we will open it and we will take the amount of 5 candies. Now, inside the box 1, it contains another box 3. But till now, we do not have a key for the box 3. So the box 3 will remain closed. So far, we have found in total 7, 4 and 5 candies. In total, there are 16 candies. So we have to return 16. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, let's try to visualize the problem into the real life scenarios. Here, into the real life scenarios, we will first open all of the initial boxes. Suppose initially we are given 3 boxes here. So we will open the boxes, first one and the third one. Now, after that, we have to open all of the boxes whose keys are present in these boxes. Suppose this first box has the key for the box 5. So after opening the first box, we have to open the box 5. Now, after opening the boxes, we have to collect the candies in these open boxes and we have to queue all of the boxes that were inside of this box. Suppose this first box inside have the box 5 and 4. So from this box, we can open the box 4 and 5 and store it Candies. Now, into this iteration, this is the new boxes we have. So we now move to the new boxes that we just got and repeat the same process for this. But the only difference is that if they are closed and we don't have any key to it, or we don't have any key to open it, then we should store these boxes for the future purpose. Suppose currently we are at this box 4 and we cannot open it. So we will store the box 4 into somewhere such that after some of the iterations, if we find the box 4 key, we can easily open it by using the corresponding key of the box 4. So that's it. This is the exception for this iteration. If any of the boxes does not have the key right now, or we can say that we do not have the key of any of the boxes, we have to store the boxes into a separate data structures such that after some of the iteration, if we find the key, we can easily open the boxes. And now we stop when all of the boxes are either opened or all of the boxes left are closed and we don't have any key to open it. Now, this is the intuition to solve this problem using the multi-source BFS. So here initially it is multi-source because we can start the BFS from all of the opening cell or opening boxes initially. So this is how basically we're gonna solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, we are given a function named maxCandies, which has a status, candies, keys, content boxes, and initial boxes array. Now we are taking a queue to implement the BFS and initializing the answer variable to 0. Now we are making a reachable course boxes vector of size of the status array initialized with false. Now we have to iterate all of the initial boxes we are given, and if their status is equal to 1, that means if the boxes is open, we have to insert them into the queue for the BFS. Otherwise, we can store these boxes for the later opening because we don't have the keys right now. That's why reachable close boxes of I is equal to true. Now inside the BFS, while the queue is not empty, we have to store the front element of the queue into a variable current, and we have to remove this front element from the queue and add the current elements candies to the answer. Now we have to iterate for each of the keys of the current element, and if the current boxes is 0 status, that means if the current boxes is closed and we can open it earlier, that means reachable close boxes is true, we can insert it into the queue, and for each of the key we have to mark the status of the key 1. Now for each of the content boxes of the current element, if their status is 1, that means it is open, so we can easily insert it into the queue, and if their status is 0, that means we can open it later because till now we don't have the key to open it. That's why reachable post boxes I will be initialized with true. After that, we have to return the answer, which is the number of candies we have taken so far. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.